Hello, I want to talk to you about standard deviation today. Okay, now this video is aimed at people who have not seen the standard deviation before and need to use it for their course. So for example, you might be doing GCSE statistics, they need standard deviation, or you might be doing A-level maths and statistics as a part of your course, you need to do standard deviation, or you might need it for something else, like for example psychology, where standard deviation might be needed to answer some of the questions in that course as well. Or it might be that you just want a little recap, okay? Or maybe you just want to find out a bit more about what standard deviation is about, okay? Because most textbooks just give you a formula. They say, right, bang, here's your formula, use it, okay? And that can be a bit scary for some people. So for example, here are the formulae that you'd use, and I can very much sympathise if you see that for the first time and think, what's going on there, what's all that about, okay? So what I'm going to do is I'm going to introduce to you what standard deviation is and why we're using those formulae, okay? I'm just going to put them away for the time being, okay, because that might just be a little bit off-putting. There, that's a bit better, isn't it? You've just got a blank board, okay? I'll give you a simple example that you can work through with me if you want, or take notes, or just watch the video once if you like it, then take notes after that, okay? But you've got 5 data values here that I've just drawn up here. 2, 3, 7, 10, 13. We normally list them, okay, along the top in a row, but because I'm going to show my working in a table, I've just presented them vertically in the column like this, okay? Now what we're often asked to do, first of all, is set data to find the mean value. Okay, some people call it the average, but it's called the mean. Don't call it average because that's a median or mode as well. Okay, and so we ask for the mean value. Okay, now for mean, we often use x bar, that's an x with a line on top, we call it x bar, to represent the mean. Okay, that's our symbol that we use in mathematics to represent the mean. Okay, of course what we do is add these together. Okay, now I'm going to introduce another symbol for you. That's a Greek letter. Okay, Greek letter S. Okay. It's sigma, it means summation of, okay. Some people think it's a Greek letter E, partly because on some, not naming any, but on some posters for adverts or films or yogurts or whatever, they tend to write Greek like that, which is just a complete nonsense, okay, because you don't spell Greek, G-R-S-S, okay. All right. So advertising goes a long way to trying to fool the general public, to make them think that that's an E, it's not, it's an S. Okay, it means summation. You add together all the values. So when I write sigma x, that means add all these numbers together. Okay, and so if you add all those numbers together, of course, we get 5, 12, 22, 35. And of course, we then divide by how many numbers we've got, and we use n to represent the number of data values. Okay, so that is a formula in symbolic terms for how to find the mean. Okay, I'm just going a little way to explain what some of those bits in the standard deviation formulae actually mean. Okay, and so we divide that by 5, and that gives us 7. So the mean value is 7. Okay, now what I'm going to do is I'm going to create some more columns in this table I'm drawing out. Okay, and I'm going to write for each data value the number 7. Why am I doing that? Well, the mean helps us to give some sort of gives us some sort of sense of what these numbers actually indicate. Okay, so as an example, if these were marks in a test, okay, this person very happy because they can see they're well above the mean. This person reasonably happy because they're a fair bit above the mean. This person, okay, I've got the mean value, not a disaster. But then these two people, well below the mean, they're probably thinking, oh, that was not really such a good test, was it? Okay, so when you get a mean value, it helps you to start already to compare all the data values, how they fit in with comparisons to all the rest. Okay, and what we're doing really is we're mentally finding the difference between the data values and the mean. So when people do a test and then they find out the mean average result, they're then quickly seeing how much above or below the mean they are. Okay, mathematically as a calculation, we require that as x subtract x bar. So if I do that, if I do 2 subtract 7, negative 5, the negative means it was 5 below the mean. 3 subtract 7, that was 4 below the mean, negative 4. 7 subtract 7, that was the mean exactly. 10 subtract 7, 3 above the mean. 13 subtract 7, that's 6 above the mean. Okay, so you can see it helps us to give some sort of meaning of the actual data values. Okay, that's what the mean actually represents. Now, what is the mean of those? Now you could call those deviations from the mean, how much each of these values deviate from the mean. Okay, if we found the mean of those, what do we get? We get 0, don't we? Okay, we get that, 0, that, yeah, it's to 0. That's always going to happen. Okay? always going to happen? Why is it always going to happen? These are the sorts of questions your textbook should be posing or explaining to you. Why do you always get 0 when you add those together? Well, it's because of the mean value, really. Okay, you're going to get a lot of data values above the mean, a lot of data values below the mean, and they're all going to balance each other out. That's how the mean works. That's what the mean is. It's a centralized figure that gives you an idea of what each of the data values represent. Okay, yeah, and so approximately half above, half below, and they're all going to balance each other out. Okay, so finding the mean of those is not going to be helpful. It's because of the negatives. Okay, so what we're going to do is we're going to square those values. Okay, you can't just simply say, well, let's just actually make that 5, 4, keep that 0, 3 and 6. That's what a modulus function does, takes an absolute value. Okay, I'll explain why we can't just take the modulus of those in a few minutes. Okay, but if we square all these data values, then all of those are going to end up being positive. 25, 16, 0, 9, 36. Okay, and we can find the mean of those quite easily. Let's just sum them together. So that's going to be 36, 45, 50, 70, 86. Okay. Sorry for the way I added those together. It's just it makes it easier for me when I'm doing it mentally to just pair certain values together and do an addition that way. So we get a value of 86. Okay. Now if you find the mean of that, 86 divided by 5, because there are 5 data values, that's going to give us what? 17 and a fifth. Let's call it 17.2. All right. What does that mean? Well, we call that the variance. Okay. I'll just write it down actually. Call that the variance. I'll rub it off in a minute. Call that the variance. It stands for the mean of how much each of the squared values deviate from the original data values. Okay, which is not really easy to say. Okay, and it's rather long-winded. Okay, that's why it's just called the variance. All right. Now, that's not the standard deviation, because what we did in finding the variance is we squared these values. You shouldn't really just square a set of data values for no good reason. Okay, if you could do that, if you could square them, you should square root again, because the inverse operation of taking a square is square root again, as long as it's a positive square root. Okay, and so we square root those values, all right, and that is the standard deviation. Okay, we use the Greek letter sigma, not to confuse with the other one. That's a small sigma. Okay, to represent standard deviation. Okay, and this is when you get your calculator out and you work out what that is. So here, everyone should have their calculator handy, of course. So square root 17.2, and that equals so 4.14 something. Okay, you can round it if you want, 4.15. Okay, that's our standard deviation. Now I'm going to show you the formulae again. There they are. Okay, and what we've done is we've worked through this example using that formula there. Okay, I'll show you how it works. Right. So always do the bits in brackets first. So the x minus x bar, that's this column here. Okay, and then squaring them, that's this column here. And then the sigma goes before it, that's adding those together. So this bit on the numerator of the fraction is adding those together to get 86. Okay, and then divide by n, divide by number of data values. So that's this, 86 over 5, the square root. So this bit of the formula you see here is just that. Okay, just the table shows you, hopefully, what is actually going on with the data figures. Okay, now I'm hoping that explains to you why this formula works. Okay, the better formula to use really is that one, because it's quicker. Okay, this one is useful when it's set out like this to help you understand what is going on. And I'm hoping you've got an appreciation of what standard deviation is actually all about now. Okay, it's about how much each of these data values are varying from the mean, and then we're squaring those values, called the squared deviations from the mean. Then we find the mean of that, the mean of the squared deviations from the mean. That's called the variance, and then you square root it. Okay, play that bit again if you want. Okay, because you know, when I'm talking quickly, I make more sense in my head, but you probably think, oh, I wish you'd just say that again more slowly. That's the advantage of a video. Okay, you can actually rewind it and listen to it again. Okay, you can't do that in class, can you? Now, what I'm going to do is I'm just going to work through the question again. Okay, I'm going to work through the question again. But this time I'm going to use the second formula. It's what I call the preferred formula. Okay, so frequently what you've got with a standard deviation question is you've got the figures listed out like that, okay? And you're asked to find the mean and standard deviation of it. If you're asked to find the variance, fair enough, just don't square root it at the end. It's that simple, okay? So if you're asked to find the mean and standard deviation, you'd find the mean first of all, you add them together. So I can't remember what that was, I'll do it again. So 23, 30, oh, it's of course 35, because then when we divide it by 5, we got 7, didn't we? Okay, so that's quickly done. Then when you're asked to find the standard deviation, okay, you can now, if you want, use this formula, which is what I'm about to do. Okay, right, what does it say you have to do? Well, first of all, we have to square the values. Okay, we square all the different values. So if we square these values, we're going to get 4, 9, 49, 100, 169. Okay, then it says we have to add them together. So when I write that down, I'm going to add them together. Okay, the sigma x squared means you do 4 plus 9 plus 49 plus 100 plus 169. Okay, so that's all of that. All right. And then you need to divide by the number of values there are. So divide all that by n, there are 5 values. And then subtract the mean squared. So the mean is 7, so we just subtract 7 squared. I'll write that in as 49 if you don't mind, because that's what 7 squared is. And then you must not forget to square root it. Okay, if you want to find the variance, that is it. But then you square root everything to find the standard deviation. Okay. Now we should get exactly the same answers as what we had before. Okay. So let's just work through this. So you add the numbers at the top first of all. Add the numbers on the denominator. Okay, you should get 331. So I'm just going to rewrite that as 331 over 5. Subtract 49, and then square root everything. Okay. What I normally do is I normally work out what's under the square root bracket. Okay. So that's, yeah, 17.2, which is exactly the same as what we had before. Okay. If you are using both methods to do it, okay, both the table method, the first formula, or this second formula method, you should get exactly the same answer, of course, right? And I can't remember what that was as a decimal when I square rooted it. There it is, 4.14 dot 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 4.15. I said 2 decimal places. Okay, and that is it. Okay, that is the standard deviation. It gives you a numerical value. Okay, and you don't have to do anything more with it. Okay, well, that's just a first simple video, I hope, in explaining how the standard deviation works and how to calculate it. I've got a couple more videos. Okay, one that looks at what happens when you've got data in a frequency table. Okay. And another one that looks at what happens when you've got data in a grouped frequency table, okay? And somewhere in one of those videos, or if I don't quite fit in, I'll do another one talking to you a bit more about standard deviation, okay? So quicker methods of finding it, okay? I'm hoping that was helpful to you, okay? And I hope to see you again soon. Bye-bye.